Hello and welcome to Mrs. Law's class. In this video, I'm going to show you the concept of logarithms. Now, actually, to understand logarithms, I'm going to actually have to first review exponential functions. Now, recall that the inverse of a function, in particular the exponential function, y equals 2 to the power of x, is x equals to 2y. So what I've done is I've swapped my x and y value. Now we need to isolate y to find the inverse. Now we don't know how to do this yet. So this is where log, or the logarithmic function, comes in. So I'm going to write this down and then I'll explain it after. So the inverse is going to be log base 2, which can write a little 2, kind of a little bit below the line. And then we have an x, which is at the same height and same size as the word log, and that equals to y. So what this means is that y is the exponent of base 2. So we can see that here. Y is the exponent of base 2 that will give us the result x. And that can also be rewritten as log with x with a little 2 squeezing between the log and the x, and that equals to y. So what we have is the exponential function, y equals b to the x, and then we have the inverse, x equals b to the y, or log with little b, x equals to y. So on this right side, the logarithmic function, these two are identical, x equals b to the y, and the log x with little b equals y. The first one is called exponential form. So it's just a form that we've written in. And the second one, we can call it the log form. So whether it's an exponential log form, these two are equivalent. All right, so I'm going to write this in the box. So we have x equals b to the y is the same as log base b x equals to y. So notice the log, the x, and the y are written in the same size, and the little b is written a little bit smaller in between. We can actually call it a subscript. So notice that this is our base. In log form, this is our base. And the exponent is where we typically think where the exponent is in exponential form. But in log form, notice that the exponent is actually the answer. Now, something that's important to note is that the base, the b value, has to be greater than 0. It cannot equal 0. And b can also not equal 1. Now, the reason that it can't equal 0 or 1 is because when we have a base b of 0 or 1, the y value can be any number, and it will still give us either 0 or 1. So therefore, we can't have a base of 0 or 1. Now, why b has to be greater than 0? We're going to take a look at, why b has to be positive, we're going to take a look at that later on. All right, so the first thing that I want you to know how to do is to change back and forth between these two forms. So it is very useful to know because we're going to be doing lots of questions that require you to change back and forth. All right, so to change to exponential form, this is probably easier because it's easier to understand because we already know the exponents of values. So here we have 5 is our base to the power of 4, which equals 625. So we know that one. So that's why it probably makes it easy too. Same with the second one. Here we have 6 to the power of -2, and that equals 1 over 36. Easy because we know the numbers. So in this last one, we have a base of a. Our exponent, remember, is the value, not attached to the log. So to the power of c, and that equals b. All right, if you want to pause the video, you can do that now and see if you can change these exponential forms and change these exponential forms into log form. All right, I'm going to do this for you, so let's practice together. So we have log, the base is 2, and our answer is 8, or the value we're logging is 8, and that should give us an exponent of 3. In the second one, we have log base 3. The value that we're logging is 1 over 27, and we should get an exponent equal to -3. All right, last one, kind of a general with no numbers, so it's harder to see or check. We have a log base x, z, and that equals to our exponent y. All right, the next thing we're going to take a look at is something called common logarithms. So whenever the base of a log is not given, so you'll sometimes see log in a number, we're going to assume that it is a base of 10. So your calculator also assumes a log with base 10. So you'll notice on your calculator, it just says log, and it doesn't have any different bases on there. So if I gave you a question and I said log 100, this actually means what power of 10, because our base here would be 10. So log, actually that doesn't look so good. So I'm going to actually write this as log with little 10 here. So log base 10, 100. So what power of 10 gives 100? So we can think of that as log 10, 100. It will give us some exponent, which we don't know. So we can write this in exponential form, 10 to the power of y equals 100. So that number has to be 2. So if you're still, this is probably new for all of you. If you like, we can write these all with an x for now, kind of to give you a sense of what you're solving for. Okay, so in this first one here, we have a base of 10 because it doesn't say. So 10 to the power of x is equal to 1. So what does that value have to be? X is equal to 0. Any base with a power of 0 is going to equal 1. Next one, we have 10 to the power of x equals 0.1. Now you might not like 0.1, so we're going to change that to 1/10. And we can see that this exponent has to be a -1, so that we get the fraction 1/10. All right, next one we have 10 to the power of x equals 1,000. And then in this one, x has to be 3, because 10 to the power of 3 is 1,000. Now the last one is 10 to the power of x is equal to -100. Now in this case, there isn't any way that we can have any exponent to give us a negative number, unless 10 already started off as negative. But 10 can't be negative because it's already just 10. So therefore, this one has no solution. In the next set of examples, we're going to take a look at why it's actually nice to know how to change from log form to exponential form. So here we have log base 3, 243. So if we set this equal to x, remember that this would mean 3 to x equals 243. So what power of x will give us 243? Well, if you know your base 3 times tables, x would equal to 5. All right, the next one here, let's evaluate these. So we're getting a little bit more complicated. So if you still want to use x, we can do that. So I can show you that. Makes it a little bit sometimes easier to understand. And then afterwards, you'll maybe see a pattern that we actually don't always have to do this. So we have 2 to the power of x equals 32. So in this case, x is equal to 5, which makes sense. So remember, so log 32 with a base of 2 means what exponent will give us 32 if the base is 2. Now this next one's a little bit more complicated. So let's rewrite this as 9 to the power of x equals the 5th root of 81. So that's our first step. So then we have 9 to the power of x equals 81 to the power of 1/5. and then 9 to the power of x equals 9 to the power of 2, and then we have to times it by 1/5, so that would be 2/5. So therefore x is equal to 2/5. So not that we have x, but this means that this expression, log with a base of 9, the 5th root of 81 is equal to 2/5. Now in this last one, this is kind of an interesting one. So we have 11 to the power of x equals 11 to the power of 7, because this whole value here is the number that we are logging. So in this case, x equals 7. And this actually will be a very useful property that we're going to take a look at later on. So notice that the base is 11. The value that we're logging also has an 11 with an exponent of 7. And that actually gives us an answer of x equals to 7. All right, these last three here, we have the x's located in different places. So here we actually need to write this in exponential form. So x to the power of 4 is equal to 81. So either you can think, okay, what base to the power of 4 is 81? We know that's 3. Or we can also think of this as, we can take the 4th root of both sides, or to the 1/4 power of both sides. But either way, x is equal to 3. In the second one, we have 4 to the negative 2 equals x. So that's great. X is already isolated. So we can see that x is 4 to the power of negative 2, or 1/16. And then the last one here, we have 16 to the power of negative 1/4 equals x. So x is equal to, now I don't like the negative exponent, so I'm going to rewrite this as 16th to the 1/4. Or we can think of this as 1 divided by the 4th root of 16. So in this case, this is going to be a half. So you can see that being able to change from exponential form to log form and log form to exponential form is actually going to be very helpful for you for questions later on.